Hi friends, here in this video we are going to see how to draw a cam profile for a roller follower, and for that here is the question. Now whatever is given in this question, I'll write that in the form of data. It is given the following data relate to a cam profile in which the follower moves with s.h.m during lift. So with s.h.m during the lift, it means during the outstroke. So I am writing theta out. That angle we are going to see it later what the value is given, but it is said that the outstroke is with s.h.m, simple harmonic motion, and returning with UARD, that is uniform acceleration and retardation. So return stroke, which is theta suffix r, is with UARD, uniform acceleration and retardation. Then the minimum radius of the cam is 30 mm. And roller radius is given. It means the type of follower is the roller follower. I am writing the type of follower in the data. This we have to mention in every problem. Here it is roller follower. Then the lift of the follower is 45 mm. Lift, also called as stroke, is 45 mm. Then angle of ascent. Angle of ascent is 70 degree, which is nothing but outstroke with s.h.m as mentioned. Angle of descent is the angle of fall or return stroke, 120 degree with UARD. Angle of dwell between ascent and descent is 45 degree. So theta d1 first dwell is equal to theta d2 second dwell, and both are same as 45 degree. Next, draw the profile of the cam when the axis of the follower passes through the axis of the cam. It means it is an inline follower. So here in this problem we have an inline roller follower. It can even be offset follower if the distance between the axis of follower and cam are given. It means it is an offset follower, but here in this case it is an inline follower as mentioned, so we have to solve the problem by taking it as an inline follower. Now into the solution part, the first step would be to draw the displacement diagram, and I am starting with that. In step number 1 we have displacement diagram, and in order to plot it, the lift is given as 45 mm. So I am projecting a light vertical line over that. I am taking the height as 45, that is the lift given. Drawing light horizontal line. It is mentioned that the outstroke is with s.h.m. For that, take the half of this lift or height. It is 45, so that is 22.5, and mark the center. Then from this center, draw a light semicircle, keeping this center and radius equal to half of the lift. This procedure needs to be followed for s.h.m or simple harmonic motion. Then after drawing this semicircle, dividing that semicircle into 6 equal parts. Taking each angle as 30 degree. Drawing light line, whatever I am drawing in green, that indicates the light line. So I have divided the semicircle into 6 equal parts. Now I'll give the notation over here, starting with 0, first, second, third, fourth, fifth, and sixth. Then, as the outstroke is 70 degree with s.h.m, so I would be taking the scale as like 1 centimeter is equal to 10 degree. So since this is 70 degree, it would fit into 7 centimeters. Dividing it into, I'll be dividing it into 6 equal parts. So I've taken first of all 70 degree, which is 7 centimeter over here, indicating the outstroke. Now this 70 degree needs to be divided into 6 equal parts. For that I am following the procedure. Like for example, if it would have been 60 degree, then I would have taken 1 centimeter as 10 degree and divided it into 6 equal parts. But here since the angle is 70, so the value would be in decimal, so it is better to divide it in this way, which I am showing here, into 6 equal parts. Measure an angle which is an acute angle, taking the value either in between 10 or 20 degree. I am taking it as 15 degrees. This is the procedure of plotting equal divisions. Drawing light line to get this angle. Now I would be dividing this angle into 6 equal parts by taking 1 centimeter distance into the compass. So I've taken 1 centimeter distance in the compass and dividing this inclined line into 6 equal parts. And then the last division would be connected to this end where the outstroke is ending at 7 centimeters. And then I'll go on drawing parallel lines considering this line as the reference. So here we can easily see the 6 divisions, and this is the manner in which it should be divided when you are getting the angle value in terms of decimal. So giving the notations over here, starting with this is 0 first, 1, then it is 2, 3, 4, 5 and 6. So these are the outstroke. Now plotting this point 1 upwards, that is drawing a light vertical line, and then projecting light horizontal line from the semicircle. I am getting the first point which is at the intersection of these two lines. Similarly 2 would be projected upwards, and then from the semicircle I am projecting point number 2, then point 3, projecting from the semicircle, next point 4, point 4 from the semicircle, then point 5, projecting from the semicircle, and finally here we have 6 and 6. So these are the points which I am getting. First I'll join them with the help of a light curve. So this indicates the s.h.m motion or the simple harmonic motion, then making it dark. Now as they have given the roller follower, this displacement diagram would indicating the upward motion of the roller, and these are the centers of the roller which would be moving up. So at first the roller is over here, then it would reach point 1, and in order it will be ascending up considering the center of roller as the reference, and finally it would be reaching at this top position. So this indicates the ascent of the roller follower during the outstroke. Next, the dwell is given as 45 degree, and during the dwell the roller follower will remain at the same position. So for dwell I can just draw a light vertical line at some particular distance. Not exactly to scale because it is dwell. Light vertical line. Dwell 1, theta d1, which is 45 degree. Then after that we have the return stroke, and that is given as 120 degrees. So I am plotting here. Taking 1 centimeter as 10 degree. So I am getting 120 degree as 12 centimeter. Now this 12 centimeter would be divided into 6 equal parts. For that 2 centimeter would become 20 degree. So these are the 6 divisions for the return stroke. (120 degrees). So 1 centimeter was 10 degree, and I have divided it into 6 equal parts by taking 20 degree, that is 2 centimeters. So now giving the notations over here as well. Since it is dwell, so this is 6, and here the points would be in the reverse order, that is 5, 4, 3, 2, 1 and 0. After that there is another dwell of 45 degree that need not be shown completely, so I am just showing it with the help of a broken section which indicates the dwell for the remaining angle. So that is dwell 2 of 45 degree. Now it is given that the return stroke is with UARD, uniform acceleration and retardation, and how to draw for that. Project a light vertical line from the midpoint of the return stroke, that is point number 3. And now since this lift was 45 mm, I need to divide this lift into 6 equal parts, and for that also I am following the same procedure which I have done here for the outstroke. That is, from here I am measuring an angle which is an acute angle. I am taking it as 15 degrees, drawing a light line at this particular angle, and then taking 1 centimeter in the compass in a similar manner like I had done for the outstroke, dividing this line into 6 equal parts. Next, connect the last division to this point O, which is the height or the lift, and then drawing parallel lines with the reference. So here whatever the divisions I am getting, I'll project it on this midpoint. So I am getting 6 equal divisions here and giving the notation to them. It is 0, 1, 2, 3, 4, 5 and 6. Now since it is return stroke, drawing a light diagonal connecting the midpoint point O and from where the dual is ending, drawing a light line. Next, whatever the points are there above this diagonal, that is 4, 5 and 6, would be connected to this point, and the points which are below would be connected to point O. And now here this point number 5 would be projected up onto this diagonal which is connecting point 5. So here I am getting a point. Next, for 4, then we have 3 at the midpoint, point number 2nd on 2, and finally point 1. So after this outstroke, there is a dual for the next 45 degree of cam rotation, and here I'll be connecting all these points with the help of light curve for UARD motion, making it dark. So this is the uniform acceleration and retardation motion for the follower fall, and finally it will dwell for the remaining 45 degree. And just to explain this, the roller is at the top during the dwell at the same height, taking the centers as the reference, and it will start falling during the return stroke. These are the centers which are shifted, these rollers, and finally it will return to the original position. These rollers are not to be shown on the displacement diagram. I am just showing it so that we can understand how the follower movement takes place. Now this completes the step number 1. Next, step number 2 would be the cam profile. So let's get started. Now for the cam profile, drawing a light horizontal line and a light vertical line. After that, I'll draw the base circle whose radius is given in the problem as 30 mm from the center, keeping the radius as 30, drawing a light circle. After that, the roller radius is given as 10 mm, so I'll take 10 mm distance into the compass, and where this base circle is ending, I'll cut this line that will give me the center of the roller, and from this point, intersection point, I'll draw a circle which indicates the roller. So here is the roller follower, and now this is the center of the roller. After that, from this same center of the base circle up to the roller center, I am drawing another light circle, and this circle is called as the prime circle. That is from the center of the base circle to the center of the roller, we have a circle called as prime circle. And in case of roller follower, the references are to be taken from the prime circle and not the base circle, because this is the base circle. So the references are to be taken from the prime circle if it is a roller follower as given over here. Now, since in the problem nothing is mentioned about the direction of rotation of the cam, So here I am assuming that the cam is rotating in a clockwise manner. So when the cam is rotating in a clockwise manner, measure the angles which are given in the problem in an anti-clockwise sense. So starting with 70-degree outstroke from this center, I am taking the angle as 70-degree. Drawing a light line from here. Next, now I need to divide this 70-degree angle into 6 equal parts, and for that, when it is 70-degree and I have to divide it into 6 equal parts, the answer somewhere it comes around to 11.6 degree. So I would be taking the angle, it is close to 12 degree we can say, and dividing it into 6 equal parts. So I have divided this 70-degree angle into 6 equal parts, and giving the notation, this line is 0 initial position, then first, second, third, fourth, fifth and sixth. Now this indicates the outstroke of 70-degree. After that there is a dwell for 45-degree. So where this line ends, I'll measure 45-degree angle in an anti-clockwise manner. Since it is dwell, the notation will remain same. It is 6. After that there is a return stroke of 120-degree, measuring with the help of this line. 120-degree, and then I'll divide this angle into 6 equal parts, so 20-degree each. So here I have divided 120-degree into 6 equal parts, joining all the points. Now once I have divided the angle of the return stroke, giving the notations to these lines in the reverse order, and the remaining part is the remaining dwell, which is of 45-degree as mentioned in the problem. Marking all the angles here, giving the dimensions. And the remaining is the dwell. Now I need to plot the points. For that, starting with point number 1 onto the outstroke, for that I would be needing the displacement diagram. And here from this point number 1 up to this vertical height, I am getting point 1. Taking prime circle as the reference, marking onto this first division of the outstroke, here I am getting the first point. Next, for point number 2 onto the outstroke, keeping on the second division, and from the prime circle, cut this line. Next, for point number 3, measuring the distance, keeping on the third division, cutting this line. Then fourth division, keeping on the prime circle onto the fourth division, Next, fifth. At last, point 6. Same height is there for the dual as well, so I'm marking it on point 6 over here as well. Now these points which I have drawn indicate the movement of the center of the roller. So in order to complete it, these are the roller centers which I have got. I am taking the roller radius which is 10 mm, and from these points we need to draw the circle, but there is no need to draw the complete circle. We can just draw a part of the circle as I am showing here. From the first center, then from the second center, next from the third, keeping the same roller radius, fourth, fifth, and sixth. No need to draw the complete circle. Similarly here. Now the sequence would be to draw a curve joining or making tangent with all these circles of the roller. So we have to draw a smooth curve connecting all of them, and just before that I would be explaining that I am joining the centers first with the help of light line, because parallel to these centers, like this curve, I am going to get the actual cam profile. Next, in a similar manner I would be drawing it for the return stroke as well. So taking the distance for point number 5, point 6 already has been plotted for the dual. So from 5 up till this height, here I am getting 0.5. Keeping on the prime circle and cutting the line passing through this fifth division. Next, for point 4, keeping on the prime circle, marking onto the fourth division. Then for point 3, in order, keeping on the prime circle, cutting the third division. For point second, and at last for point 1, keeping on the first division. Here I am getting the center. Next, these are again the centers which I am getting. So taking the same roller radius and drawing the circles from these centers, but not complete circles, because we would be requiring only the base tangents. And finally we'll reach this point 0. Now again, like I've connected these centers, I'll be joining them. So this is the curve which I'm getting by joining the centers. Now parallel to this curve will move the cam profile connecting the base tangent starting from this point 0 parallel to this curve, and this curve is called as the pitch curve. I'll write it over here. pitch curve joining the centers. Parallel to the pitch curve would be the cam profile, joining the base tangents. After drawing this curve light, now I'll make it dark, which will be the final cam profile. Joining the base of the circles. With the help of a smooth curve, and whatever portion is remaining here, that would be a part of a circle. So this is the cam profile, and we can see that it follows the pitch curve. Pitch curve needs to be drawn in this way, like a center line. Here I'll make this roller dark. At the center I'm drawing a shaft which is called as the cam shaft. Because of this shaft the cam gets power, connected with the help of keyway. This is the axis of the follower, in line with the axis of the cam, as we can see here. Here is the pin which joins the follower with this ruler, and I'm showing it with a broken section. And at the same time we have guideways over here which prevents the lateral movement of the follower. So these are the guideways. Follower would be just reciprocating. Here is the roller, and this is the given cam profile as mentioned in the question. Outstroke would be covered by s.h.m. Then there is dwell of 45 degree. For the remaining 120 degree it is return stroke with UARD, and finally the last dwell. And that was the cam profile. At the end, if you all find my videos helpful, you all can like, share, comment and subscribe our channel and share it amongst your family and friends. Thanks for watching.